This is the electrolyte experiment. I'm going to add electricity to different substances for us to then figure out if a substance is an electrolyte or a non-electrolyte. We'll also then be able to tell if an electrolyte is strong versus weak. So a couple things to note that should have been in your notes that you need to make sure you understand is that a non-electrolyte will not dissociate. It will not conduct electricity at all. So this would be some sort of molecular or covalent compound. You need to have ions that will separate in a solution for something to be an electrolyte. So if you have a strong electrolyte, like let's say HCl, hydrochloric acid, and it has to be aqueous, so AQ, this will dissociate. So it's not like this is reacting with anything, but in water, you will get a separation of your ions, which will then both be aqueous. And a strong electrolyte is when all of your initial substances turns into ions. So we don't have any HCl together anymore. We only have H plus and Cl minus ions. A weak electrolyte, on the other hand, is when only some dissociates, only some ions exist, and you still have some of your starting material. So let's say you have aqueous acetic acid. The arrow looks like this, where you're going to get like a double arrow. You're going to have some of it that's gone this way, but some of it that's also staying back this way. So you've got your H plus ions again, but then you've also got acetate negative ions. So in this case, all that would exist when you dissolve the HCl in water is this is what you'll have in your beaker, these two things. Whereas in a weak electrolyte, you're going to have these, but you're also going to have some of these that are together. So what my little apparatus thing will show us is I've got two prongs right here, two electrodes. So if I can connect them somehow, electricity will flow. So I've got a wire here just to show you how it works. So if I touch both sides, you can see the light bulbs light up. Now what's cool is I have two different light bulbs. This one takes more voltage. It's going to need more electricity to light up. So we will be able to tell if it lights both of these up, we've got a strong electrolyte. Versus if I unscrew this, if it doesn't light either of them up and I unscrew this one, a weak electrolyte will be able to light up just the weaker bulb. So a non-electrolyte will be no electricity, no light bulbs at all light up. A strong electrolyte will be both, and a weak electrolyte will be just the little one. All right, so I'll go through your list. So the first thing we have is sodium chloride aqueous. So I took salt and I dissolved it in water. And all I'm gonna do is put the two prongs in here, and we've got both of them that light up. So note that in your data table. That was aqueous sodium chloride. All right, I'm gonna wipe it off in between each one. And don't worry, I unplug it every time because no one needs to see their teacher get electrocuted. All right, here I have just solid salt crystals. So no water in this one. So salt dissolved in water dissociates as a strong electrolyte. Plugged it back in, but solid salt by itself, no water, does not dissociate. Remember, it has to be aqueous for this to happen. So solid salt, nothing. All right, make sure this is clean. All right, the next one on your list is distilled water. So distilled water, remember, is pure water. So it is just H2O. And distilled water, it should, and then we'll check, should do nothing. Remember, distilled water is pure water. H2O is a covalent compound. We've got covalent bonds. They're sharing electrons. So there are no ions in here. So this is a non-electrolyte. Okay, now tap water, remember, is different. Tap water has minerals and other things dissolved in it. Depending on where you live, you're going to have different minerals and substances, or like fluoride, let's say if you have city water. So tap water, we'll double check. It's not a strong electrolyte, but it does light this one up, so it is a weak electrolyte. Okay, next one I have is sugar water, sucrose solution. So I just took sugar, I dissolved it in distilled water, because we want to see if the sugar will do anything, not the tap water. So I put sugar water here. It's not weak, not strong. So this is a non-electrolyte. Okay. My next two are both HCl, both hydrochloric acid, but there's a difference. That M there stands for what we call molarity, and that's something we're going to get to later in this unit. So the higher that value, the more concentrated it is, meaning the more of whatever your substance is. So in this case, 6 molar HCl has more HCl than the 1 molar HCl. So let's put 1 in first. Woo! We got a strong electrolyte. All right, let's see if concentration makes a difference. So I have a higher concentration. There is no difference. It dissociates the same regardless. So concentration does not matter. Okay, my next one is NaOH, sodium hydroxide. Remember when you have a metal and a non-metal, or like a metal and a polyatomic ion like this, sodium's our metal, hydroxide's our polyatomic ion, we have an ionic compound. Ionic compounds should all be electrolytes because they consist of ions. Okay. Next on your list is C2H5OH. We've got ethanol. So ethanol or ethyl alcohol. You can look up its structure to see what it looks like. You built this last year with the model kits. So it's not strong and it's not weak because we don't have a metal. We don't have ions in here. Okay. Our next two are both acetic acid. Now acids, like hydrochloric acid, acids are made of ions. Remember the cation in all acids, at least for now, is going to be hydrogen, and then we have some anion with them. So acetic acid, we have hydrogen, and then we have acetate. So I'm first going to do what's called glacial acetic acid, and you might want to make note of this. Glacial means it is pure, like there is no water. This is pure acetic acid. Acetic acid you have at home as vinegar. At home it's probably 5%. That's typical vinegar concentration. This has 0 water. So this would be like 100% acetic acid. So acids are made of ions, but this is a non-electrolyte. So think about why this one's a non-electrolyte. Just because it's a liquid doesn't mean it will dissociate. It's just like the table salt, solid ions versus the salt solution. It needs water to dissociate. So if I had a liquid here, an L here, this would not happen. So let me show you when I do have aqueous acetic acid. So this is 6 molar. So this one, we'll double check. It's not strong, but it is weak. So when there is water with it, it can dissociate. When there's not, it will not. All right, one more for your data table is ammonia, NH3. Ammonia is a weak base. We will learn more about bases and acids later, but a weak base, this would be, I'm going to say this is a weak electrolyte. But weak bases, just like acids, are also electrolytes. Bases and acids are both electrolytes. This one will be weak. Okay, so that should be all of your data. You have more to fill in on that table and then some questions and some equations to write. But just for fun, I want to do one more. You don't have to add this to your data table, but we talk about Gatorade as having electrolytes. You've heard it in the ads, you've seen it on the bottles. You've probably thought, oh, I need to replenish my electrolytes. No, probably not. Okay, so I have Gatorade right here. So let's see, does Gatorade actually have electrolytes? Think about it. Are they telling us the truth? Oh boy, here we go. It's not strong, but it is weak. So Gatorade does have electrolytes. If you look at the bottle, it's going to have things like citric acid, sodium citrate. I can't remember all the names that are in there. But any of those ionic compounds are going to be electrolytes. So there you go. That is your data for your electrolyte lab.